discussing X-ray interactions with matter and the 5 different interactions that interacts with our body and matter. Photoelectric absorption, Compton, coherent, pair production, and photodisintegration. First, I'm going to start talking about photoelectric absorption. For example, this is an atomic model of calcium, which has an atomic number of 20 electrons and contains in the bones. When we do X-ray on the extremities, the bones is going to absorb the X-ray photons. The radiographic image is a result of the X-ray photons in the primary beam interacting with different atoms in the body before reaching the image receptor. The X-ray photons may be transmitted, absorbed, or scattered in a new direction depending on the energy of the X-ray photon to begin with and the type of tissue the photons encounter. The photoelectric X-ray interaction with matter describes photon absorption at the atomic level. At the beginning of the photoelectric interaction, an incident X-ray photon enters the atom and transfers all of its energy to a K-shell electron. This energy transfer results in the ejection of the electron from its orbit. The ejected electron is called a photoelectron. This ionization event creates a vacancy in the K-shell of the atom. To restore its neutral charge, the atom fills the vacancy with an electron from the outer shells, usually the L shell. The atom continues to stabilize itself by having an electron from the M shell to fill the vacancy left of the L shell vacancy until all of the shells once again are filled. This movement of electrons is termed a characteristic cascade or a cascade effect, and it is essentially the same process that encounters during characteristic X-ray photon production. To satisfy the law of conservation of energy, a characteristic X-ray photon emerges which is equal to the difference between the two electron shell binding energies. It is important to note that due to low energies of the photons produced in this matter, few of any of these photons are able to exit the patient. Photoelectric interactions are more likely to occur in bone compared to other tissues in the body because this is relatively high density and an atomic number. This is why all bony tissue and radiographs appear white. The X-ray photon completely is absorbed by the bone and is therefore unable to reach the image receptor. When the X-ray photon strikes the inner shell is ejected, and this electron absorbs X-ray photons, producing a photoelectron, which is matter and energy. Consequently, electrons from the other shells jump and release the secondary radiation, and this interaction increases patient dose. This second interaction is Compton. This interaction occurs when the outer shell electron and a high energy photon strikes the matter, and the outer shell electron is ejected, a recall electron, and scatter radiation. The scattered is our enemy because of produced fog in the image receptor and increase the dose occupational exposure. That is why we need to apply LoRa philosophy, distance time shielding, in order to avoid the whole body dose increase. The next interaction I'm going to talk about is coherent interaction. Coherent is also known as classical and also as unmodified scatter. So this interaction happens at least when the X-ray photon reaches an energy of 10 kVp. The reason why it's called unmodified is because incoming photon does not have a change in the frequency and wavelength. So two things can happen. The whole atom can vibrate, and that is called Rayleigh, or one electron can vibrate, which is called Thomson. No ionization occurs in this interaction. Only heat is released as a form of infrared radiation. This next interaction is called pair production. This interaction, two matters or antimatters are produced. One is a positive electron, which is also called a positron, and the negative electron, which is called a negatron. The incoming X-ray photon is at least 1.20 mega electrovolts. So this is pure energy that is produced to antimatter. The positron is going to join an electron from the tissues and is going to fuse with the positron to release two energy photons opposite directions, which energy of 0.51 mega electrovolts. The photons are produced a process that is called annihilation reaction. This interaction does not happen in diagnostic X-ray. This next interaction is called photodisintegration. This interaction happens when the incoming energy photon is at least 10 mega electrovolts and destroys the complete atom, producing a nuclear fragmentation. In conclusion, when X-rays interact with matter, they all go through attenuation, which is the reduction of X-ray photons when it passes through a given thickness, such as our skin. Attenuation is the result of X-rays interacting with matter by one of the 5 interactions: photoelectric absorption, Compton, coherent, pair production, and photodisintegration. But there are only 2 that interact with diagnostic X-rays, which is Compton and photoelectric absorption. Hope you enjoy. Thank you for watching.